And so I'm really happy to announce the next session now, which we had from the lab. HARTING guarantees reliable robustness connections for harsh environments. And they are coming from the lab. I'm really proud to introduce Stephan Middelkamp and Joachim again. Stephan.
Okay, yeah, thank you very much, Kilian. So after we have learned in which markets we are active with our products and which outstanding requirements they have to pass, we are now coming, okay, how is HARTING ensuring that those requirements are really being confirmed and guaranteed? And for this, I have today Dr. Stephan Middelkamp with me. So Stephan, maybe you introduce yourself.
Yeah, thanks for the brief introduction. I'm responsible at HARTING for quality and for the different labs we have worldwide, supporting our development and guaranteeing the robustness of our designs, which we'll see in the next roughly 20 minutes.
Okay, perfect. Thanks a lot. So then let's start. Let's jump into the topic. I would like to show or start with the sentence of Philip Harting. He is our, as you know, our CEO, our chairman, and his grandfather always said, quality is when the customer comes back and not the product. Yeah, so this is a sentence which shapes HARTING since decades, years and years. And this is a sentence really where the family and also the company are putting a lot of attention for quality, being reliable, not just for 1 hour, for 1 day, really for 20, 25 years in harshest environments. How does HARTING realize this? This is what we go now deeper into. So first of all, it's a systematic approach. It's not just the R&D. It's not just a laboratory. So it really starts with a very long-term and deep application knowledge of our complete and global sales team, product management team, and the corresponding customer applications. Because the needs are so specific at the applications itself, so means the application knowledge and the long-term application knowledge is a key point. Second point, for sure, one of the very important points is the excellent product development and product qualification. So also for this presentation, the main part, and I'm very glad that Stephan is here. And the third part is then, of course, you need to have a strict and systematic quality control in your production. This is the point where we will end with. So means quality in HARTING is a systematic approach, and all those, without one of those points you can see on the screen, to my point of view, everything would be nothing. Okay, let's go into the deep application knowledge. What we see here on the left side is our sales organization in Germany, HARTING Germany in Minden. And we have globally 44 sales organizations. Yeah, so means we are for sure also selling to distribution is a very important part for HARTING. But we take a lot of attention to have local support in each country by different product management and sales colleagues. So means a close relationship to the customer. By this, we have over years and years learned a lot about robots, about different applications inside the train. So a train is not a train. You have many different sub-applications with many different substandards and requirements. So that's very important, application know-how. And only by this we are really able to, by consulting our customers, to find the excellent product application fit. Because it doesn't play or make any sense if our sales guy sells any kind of products, and after 2 years the customer comes back and saying, oh, it was nice, and it was maybe cheap. Yeah, for this one we selected you, but it does not fulfill the requirements. Yeah, so means by our global sales and product management team, we ensure that we find the excellent product and application fit to our customers. All right, coming now to our excellent product and development qualification. I pass over to Stephan. You are the expert.
Thanks, Joachim. The foundation of quality is already laid during the development phase. There we have to ensure a robust product which will be afterwards produced in our plants and of course, checked during the production as well with normal quality assurance based on the planning we have. But nevertheless, the basis is laid in the design phase. Therefore, we put such a focus on the verification of the robust designs. And they are the hardest done in the different labs. What you see here is the main lab we have in Espelkamp. This is our HARTING Quality and Technology Center. We have additional labs in China, in the US, in Romania, and in India. Thereby, we ensure that we can optimize the design already during the whole development phase, and not only at the end, and have fast iteration cycles. Our leading lab in Espelkamp at headquarters has at the same time the role ensuring the quality of the labs, so that we use according to the same methods, even use the same tools, and whenever possible, the same machines as well. So we can check that we ensure the same quality worldwide, independent on the development location and independent on the testing location. Before coming to the future, let's have a look to the past. Where do we come from? Why is it so important for us? This gives you just a few glance of the possibilities we have in the different labs. Here you see a picture from the central lab we have in Espelkamp. You see the yellow boxes which we use to steer our products around the different stations, the different testing stations. In the middle, we have all the test engineers that we have an exchange between the test engineers, and in the outer region, we have the different test possibilities. To add some key facts, we have in Espelkamp, only in Espelkamp, something like 4,000 square meters of test space, more than 40 engineers doing the tests and doing more than 2,000 test reports every year. The lab itself is accredited according to ISO 17025 for more than 350 test standards. In Germany, we have the accreditation by the German accreditation body. In China, we did it by the Chinese one, the CNAS. The other labs are smaller, but they are able to perform the basic tests as well, therefore ensuring really already in the development phase that we are on the right way and the products fulfill the requirements according to the market. But before coming to the tests, we of course have to define the requirements. So one point for the requirements is in connector usually a product standard. When we talk about M12, RJ45 or PCB connectors, we usually have product standards where IEC experts have defined basic requirements. So this is the basis, but can only be the basis because this targets for the basic applications, but not for special ones. So therefore, we enhance the requirements of the product standard by application-specific requirements. Joachim just told us about the different requirements on the applications. So if we talk about railway, we have to add specific railway standards for vibration. If we have a machinery application, we might have additional temperature ranges because of the heating of the machine itself, or linking to energy. It might be a continuous flow of energy. which is a bit different than you have in a normal product standard. Robotics have usually high accelerations or special bending radii, which you have to take into account, etc. So this is really one core part, which are the requirements on top of the basic product standard requirements. Then, of course, we have experience with similar products. So since we use, of course, a lot of similar components, we have similar design mechanism behind this, so we can transfer the experience we have with one product to the testing requirements of the other one, thereby ensuring that each product is getting better. And finally, sometimes we have customer-specific requirements. The better we know the application, the better we can check whether it works. This might be if we're talking about special rain applications, special temperature applications, talking about minus 55 degrees if we have an Arctic train running in the Arctic area in Canada or somewhere else, or could be as well some ultraviolet or ozone requirements or some chemical requirements, or even very simple a profile, an energy profile to ensure that the connector can carry the specific current. So we have prepared an overview just to give you a glance of a typical type test plan. Of course, this does not incorporate all the specialities because this would make it much too broad. But nevertheless, just to give you an idea, the qualification of a connector usually takes us something like 6 weeks because we have some long-term storage to really ensure the reliability of the connector, long-term reliability, and something like 150 to 200 working hours. So we are always starting with initial measurements to define the baseline. We check basic properties. This is mainly the electrical properties, but might be force properties as well. What is the mating force you have? What the normal force to ensure a safe connection? These basic properties give us a baseline. Then we do some aging to simulate the application and check once again the basic properties to see whether the connector is still working after this kind of aging. Here we see the measurement of these basic properties. As the example you see here, the measurement, the electrical measurement, contact resistance on a PCB connector. And you see how we can do it automatically. So we can measure automatically the contact resistance of each pin. And this is so important for us because this allows us to do this very often. You usually have 5 connectors per test group, and as explained, you have to redo this measurement a couple of times during the type test. So by having an automatic way of measuring this contact resistance, this allows us to monitor the quality much better as if you would do it manually. Then you could only be able to measure a couple of contacts or not to repeat this measurement so often. So now coming from the functional to the aging mechanism. One test group is something like a mechanical aging. We heard a lot of vibration. So this is, does this connector work? Does the contact mechanism work a long time? Therefore, we usually start with the thermal aging of the base material, leading to relaxation of the contact force. Afterwards, we have the vibration test itself, and then adding some climatic stress. And in between of all these tests, we check the electric properties, whether the connector is still working. Here we see a vibration test. As the example of a switch with a connector, you see at the same time the function is checked. So you have a vibration profile on the switch and the connector in the application, and you check at the same time whether the function is working. This we can do with addition of a temperature, so either cold or high temperature load, to simulate really combined effects. And always at the same time checking whether the connector is still working, either, as we saw on the first application, for a switch, a real-time Ethernet protocol which we apply, or more or less a simple contact interruption test where we check whether we have contact interruption larger than 6 microseconds. Because if we have contact interruption with higher than 6 microseconds, we might lose packages for the distribution of Ethernet protocols. Coming to the next test group, that would be mechanical endurance. In the first one, we checked is the base material working? Is a contact principle working due to mechanical stress? Now we are looking onto the surface of the contact itself. Therefore, we start with the aging of contact surface, once again, a thermal aging. But then we make mating cycles, 250, 500 mating cycles, up to 10,000, depending on the application. And then we try to have a corrosion of the contact material. So do we have corrosion effects on the contact material and thereby an increase of the contact resistance? This can be simulated by this mixed flow and gas test where you apply chlorine, sulfide, and nitrogen gases to the contact itself. Once again, at first, you damage the surface by mating cycles. Then you apply these highly corrosive gases. And then you see here as a reference with copper, it's getting darker. The left one, the golden one, is fine. And the other, you see a lot of voids. To have a look on a real contact, you see the difference here as well. Left-hand side, you see contacts which are looking fine. Right-hand side, you see a lot of voids where the contacts are not looking fine anymore, indicating a corrosion. So what are we doing now then? To optimize the process, because something went wrong in the process, or we have to optimize the design. We have a scanning electron microscope, which is at the end a very good microscope, which allows us a cross-section through the surface itself, through the contact material, having a look onto the material itself. So this is how the machine is looking like. So you put the machine, the contacts inside there, and want to make this cross-section. However, it's still a microscope, so you're just looking on top of the microscope. Therefore, we have a focused ion beam, as you saw, where we can use argon ions to cut into the surface exactly at the point of this void. And then we know at which point the defect occurs. And afterwards, we can analyze the material, as you can see here, and see which kind of material used this void, use the male function or whatever. And with this information, we can then go to our plating department to optimize the plating process, and thereby having the continuous optimization. Last point is the aging, normal thermal aging, where we have a look onto the long-term behavior, like thermal behavior, dry heat, here cold, we talked about cold. This is an example of dry heat, so either with load or without load, additional temperature load. This could be a thermal shock as well, where we switch between minus 40 degrees and 150 degrees upper temperature, like with an elevator, really putting some thermal stress on the connectors, or having stronger humidity or different temperature cycles. Well, that's the same idea for checking the long-term behavior as well. Some more special test groups is the chemical resistivity. There you really have to define which chemicals could be pushed to the connector. And a separate topic is the whole connection method. Now we are only talking about the mating site. Of course, we have to qualify the termination site as well, which might be RDC, crimp soldering, etc. And the last topic, especially looking to Ethernet connectivity, is the electrical transmission requirements. There we will have a separate talk tomorrow, roughly at the same time, so I think 11:50 or something like this, or 25. So if you're interested in more details to this, how do we ensure the behavior, cut 6, cut 7, cut 8 behavior, we will have a more detailed look into this tomorrow. So now for conclusion, let's talk about from the design to production, how do we ensure this very briefly in production.
Yes, so first of all, many thanks, Stephan. Sometimes I don't know who is more stressed, our products or me, our laboratory, because they don't care about exhibitions and dates where we would like to launch our products. They are fully independent, and products who do not pass the test successfully, their colleagues will not approve and give free for sales. So really, yeah, a very comprehensive process here. Developing the products is, of course, not everything if you are not able to keep the quality in the production. So a very important part here is that you have a deepness in production, that you don't purchase too much, but that you do the stamping by yourself, that you plate the contacts by yourself, that you do the molding, and even the assembly machines. So those are all parts we have in-house in HARTING, and is a very important part to ensure the quality. And that's the part, as Stephan mentioned, which we will cover on tomorrow more in detail. All right. Thank you very much for the attention. Thank you, Stephan.
Thank you.
Thank you both. Thank you both. Thanks, Stephan. See you tomorrow again. I think that was really exciting, and I can tell you that was just the glimpse of what Stephan and his team and the whole laboratory is doing to secure the quality, the outstanding quality of the connectivity. So everybody of you who is interested and pass by in Espelkamp here in the middle of Germany, if not to say in the middle of nowhere in Germany, I can really recommend give us a call and we can organize a tour, and stamping, molding, plating, and the laboratory can all be visited by you, and we are happy to guide you through that.